A marathon is a race of a distance of 42 kilometers. A competitor starts the marathon at 8:10 a.m. and finishes at 10:40 a.m. What is a rate in kilometers per hour? So speed or velocity is a rate, is when we compare distance to time, or kilometers per hour. So the ratio is 42 kilometers. The hours it takes between 8:10 and 10:40 would be 2.5 hours. So I'm going to write that as 2.5 hours. Now it's important to understand that clock time is difficult to use mathematically because clock time is in hours and minutes. We really need to change clock time into hours, or all minutes. So in this case I converted it to hours because I want kilometers per hour. So there's my ratio. And to find the unit rate, I divide. So I take that 42 kilometers divided by 2.5 hours. I end up with 16.8 kilometers per hour. Now that is a very fast running pace for 42 kilometers. If I drive 220 kilometers in 2.5 hours, I do the same thing. I want to do my ratio of comparison of kilometers to 2.5 hours in the denominator. So there's my rate, and I can convert this to a unit rate, which is, again, these unit rates are useful because these are our multipliers in our problems. So I end up with 88 kilometers per hour when I divide. So I find the unit rate by dividing. Here I'm going to compare 350 pounds for $200. Now when I do this rate, I'm doing pounds per dollar. And again, the direction of the comparison is really important. Pounds per dollar. When I divide these, I get 350 divided by 200. And so the 1.75 that I get, the units are pounds. So I get that many pounds for $1 of cost. Now the unit rate here could also be done in the other way, because we may want the opposite ratio, or dollars per pound. So we would write the dollars on top, the 350 pounds on bottom. If I want a unit rate, I divide. This is not as nice of a number, but I get 0.571. So I'm going to round that to 0.57, and the units are dollars on top, pounds on bottom. So dollars per 1 pound. So I get 57 cents. It costs me 57 cents for 1 pound of this type of grain. Density is a rate as well. So it's a ratio of comparison. Density is not mass. Okay? We could have lots of mass, but very little, or a lot of volume, which is not a lot of density. Or we could have a lot of very little volume, but no mass. Okay? So we could have this, when we talk about density, it's not just mass, but it's the amount of mass for how much material we have, the volume of material that we have. So steel weighs, the ratio of comparison of steel, or the density, is 206.7 grams for 23 cubic centimeters. So we end up with this amount of mass for this amount of volume. When I divide the two, I get my density as a unit rate. So 206.7 divided by 26, that gives me 7.95. Now the units of density are measured in grams per centimeter cubed. So for each cube, this is how many grams I have. And that ratio represents a density. So the bigger that ratio is, the more dense or more heavy something feels. Okay? But it's not just the mass by itself. It's the mass with compared to the amount of volume it takes up. We could have, 100 grams of mass of very dense material like gold. That would be a very small amount. But we could have 100 grams of something light, something less dense like air, we could have 100 grams, but that would occupy much more space or much more volume. Okay, so that ratio of mass to size or volume, that is what we can call density, and that's a rate. A Tesla uses 47.68 kilowatt hours of energy. Okay, and it uses this energy for 320 kilometers of distance. So we're going to write this as a rate. So 47.68 kilowatt hours. That's energy, measurement of energy. And that much energy is used to travel 320 kilometers. When we divide these two, I'm going to get my unit rate. So 47.68 divided by 320. And that gives me 0. Let's see here. That's going to give me 0.149 kilowatt hours per 1 kilometer or per kilometer. That is the rate at which we use energy for each kilometer. Now we can also flip this around to get the rate for the number of kilometers that we get for 1 kilowatt hour. So we can flip this ratio to compare kilometers on top, kilowatt hours on the bottom. And again, to get a unit rate, we divide. So if I want to divide this, I end up with 6.71. Now what are my units? This is how many kilometers the Tesla can travel for 1 kilowatt hour of energy. So our rates can be in either way. We can flip them around if we want. We can actually find the reciprocal of these. Okay, but these are both valid rates, and it depends on which is a direction of comparison, and will determine which of these two rates we would want to use. So we have a problem here where we're given the amount of energy, and we want to find the distance traveled. So I'm going to write like this: 83.44 kilowatt hours to X kilometers. We don't know the number of kilometers, and we can make this comparison. We can make this as 47.68. So 47.68. As long as we're making the direction of comparison the same, kilowatt hours on top, kilometers on bottom, this would be a valid comparison. Now, mind you, we could also use the unit rate as well. 0.149 kilowatt hours for 1 kilometer. Remember that these are ratios, so this is an equivalent ratio to this one, and we're finding another equivalent ratio. This unit rate happens to be our multiplier going from bottom to top. Okay, if I multiply 320 times our unit rate, I'll end up with 47.68. So I'm going to use the same multiplier going from bottom to top. So is that the same? Ooh, this is my, yeah. So I need to go in the opposite direction now when I look at this. So I'm going not from bottom to top, but I'm going in the opposite direction. So again, the directionality of our comparison and directionality of our calculation is going to be relevant. So if I'm going to multiply going in this direction, I need to divide by that same multiplier. I need to divide by that same unit rate going in the opposite direction. Okay, so I'm going to find my multiplier here. So it's going to be 47.68 divided by 320. And I'm going to then do 83.44 kilowatt hours divided by 0.149. And that's going to end up giving me 560 kilometers of distance based on 83.44 kilowatt hours of energy. So I could still use, this multiplier here if I want to, but it's going to be, this is actually our multiplier here going from 83 to 560 if we multiply by 6.71. So this multiplier or divisor of 0.149 is the reciprocal or opposite of this, which means that if I multiply by this, I get the same result. So I'll show you how that will work. And if we keep track of our units, this really helps. So I'm starting off with, so this is the same solution for this problem, but now I'm going to show you a multiplying strategy, and we're going to end up using that unit rate of 6.71. So I have 83.44 kilowatt hours. That's what I'm starting with. I'm going to multiply, and I need to end up with my units of kilometers, because that's what I'm trying to figure out. In order to convert kilowatt hours to kilometers, I need to get rid of the kilowatt hours. So I'm going to use this multiplier, 1 kilowatt hour. Next I'm going to do it in red because I'll just show you where I got it from. I have 1 kilowatt hour here and 6.71 kilometers. That's my ratio. Okay, now my rate, the reason why I'm using this rate and not this rate is because this rate gives me my kilowatt hours in the denominator, which allows me to cancel a times with a divide. These units actually cancel out. And notice that I'm left with kilometers as my units, and that's the units that I want, kilometers over here. This is just fraction multiplication. So I'm going to times on top, divide on bottom. Well, this is times, divide is just divide by 1, so that's not going to affect it. So really, my calculation ends up being 83.44 times 6.71, and that's going to give me just under 560 due to the rounding, so I'm just going to round that to 560 kilometers. Okay, now the difference in because I get decimals here, the reason is because this is a rounded decimal here. Okay, so that would be a little bit inaccurate due to the rounding that I had to do here. However, this is called unit analysis because the units, this ratio allows us to cancel out these units, times on top, divide on bottom, and then allows us to get the kilometers units here. And that's the units that I want for my solution.